Good evening, everyone. Welcome to this interactive session for GATE. Today we'll be looking at problems in probability and traffic engineering. So last time we got a suggestion to take up questions and focus more on the problems than the theory. So this part of traffic engineering, I'll limit the theory and solve more problems from the previous year GATE problems. Before that, we had a question from this in the forum, the value of the real variable x greater than 0, which maximizes the function f of x given to two decimal places. So let us solve that first. Let me use a fresh page. So we are given that f of x is x to the power e power minus x. Where is it? Yeah, x power exponential of minus x. So we need to find out which value of x greater than 0 maximizes this function. So let us proceed in the usual manner. We know if f of x has a maximum at x, if extremum in general, either a maximum, local maximum or minimum at x, then the derivative of x should be 0 at that point. So we can take the derivative. So this is of the form u of the product rule. So you can take u of x is x power e and v of x is e to the power minus x. So f of x is of the form u of x, v of x. Therefore, f dash of x is u dash of x, v of x plus u of x, v prime of x. This is the usual product rule. And what is u dash of x? So you have x power e, and e is something greater than 1. So d by dx of x power e is e x power e minus 1. So I can write it here. E x power e minus 1 and keep e of v of x as it is. It is e to the power minus x plus now we have u of x. What is u of x? It is just x power e. And then v prime of x is, so this is again in place of, you can write it as v of x is some e power minus x. You can call this minus x as some y. So you can, so again, you can apply chain rule. So when you differentiate e power minus x, so first differentiate it as it is. So you get e power y, which is e power minus x, and then differentiate the exponent with respect to x. So I get a minus 1. Now we have to set this value equal to 0. So f dash of x equal to 0 implies e x power e minus 1, e power minus x, and there is a minus sign, minus xe e power minus x equal to 0. So in order to take things common, you can write x power e as x into x power e minus 1, so that you can take xe minus 1 commonly out, which implies e x to the power e minus 1 e power minus x minus x to the power e minus 1 e power minus x equal to 0. Now you can take this commonly out from both the terms. So you get x e power minus 1 e power minus x into e minus x should be equal to 0. So this is the So this is the expression for the first derivative. And you can clearly see we are seeking a solution x greater than 0. So x is not equal to 0. And for any positive x, for any x, e power minus x is not equal to 0. Therefore, e minus x should be equal to 0, which means x should be equal to e. And that is the only solution. So most likely it is a maximum. I couldn't get, is that right? Do you have access to the answers anywhere? I couldn't get which year of GATE it is from.
This is not from civil question paper. This question is from GATE sample paper.
Okay.
Of This
So
year
is the answer right? So they are asking to 2 decimal places. So E will come up to 2.7. Let me check. Yeah, something like 2.72 is the answer.
I don't have access to answer.
Oh, okay, fine. Yeah, but it has to be. Let me check. So the value of the real value. Okay, we can do one thing. We can check it roughly. Yeah, most likely this. But you get the procedure right. Is that okay?
Second last step where you like, how did you make out that x is equal to e?
This one?
No.
Ah.
Second last below
This one?
this.
This step?
Yes. I mean, how?
Yes. Can you? What is the like? What is difficult here?
So how did you like? How did you reason that x should be e?
Oh, yes. So this is the condition you're getting, x power e minus 1. So these are all in product terms, right? You can call this as some a, call this as some b, and call this as some c. So you have a product of a, b, c equal to 0, right? So either a should be equal to 0, or b should be equal to 0, or c should be equal to 0. So what is the condition a equal to 0? It means x power e minus 1 is 0. But if x is greater than 0, the question says x is greater than 0. So for any positive x, you cannot have x power e minus 1 equal to 0. So a equal to 0 is not correct. Then take b as e power minus x. And exponential function is non-zero everywhere in the real line. So whatever x is, it'll always be positive. So again, b cannot be equal to 0. So essentially, you only have one option, which is c equal to 0. What is c? C is e minus x. So if e minus x should be equal to 0, then x should be equal to e. Is that okay?
Oh, yes.
Yeah. So just to check if our answer is right, let us take x is going from 0 to let us take 0.01 to 4. And the function we are given is x power e. Check if e is yeah. So it is let e equal to the function given is x power e star yeah. So the maximum, if you see, maximum is somewhere here. Yeah, so the answer is around 2.72, 2.74. So that is fine. So our answer is right. So this is the function basically. If we visualize as a plot, x power e power minus 6 is a function like this. So we can check the answer we got. By calculus, what we got is I can also say Yeah, so the argument is 273rd. So what is x of 2.72? So that's the answer. So yes, so the procedure we did is correct, and we have also checked the answer. So the maximum value of x e power minus x, the maximum value is what we got. The maximum value is some 1, and that appears at, and that happens at x equal to 2.72. So that's the right answer. So is that okay? Shall we proceed with the other questions for the day?
Yes, sir.
Yeah. Yeah. So we have been looking at random variables in the last session. Let us solve these 3 to 4 problems on, these 3 to 4 problems on probability and random variables. Then we look at uh, traffic engineering. So these are, so as far as I have seen, the almost every year there are at least 2 questions from traffic engineering, and the questions are extremely simple. Unlike problems in structural engineering is also simple, but these are very simple. You would just have to do a division or some product and we have the answer right away. So that is how these questions are. Let us, so it's good to spend some time in so looking at the concepts for those questions. Let us start with this one. A pair of six-faced dice is rolled thrice. What is the probability that the sum of the outcomes in each roll equals 4 in exactly 2 of the 3 attempts? So let us take. So what is a random experiment? So we have a random experiment of. It's always a good idea to, in the beginning, you can define the event, define the experiment. Experiment is rolling a pair of dice. We are doing it 3 times. Now, are the 3 attempts? So first question is, are the three trials independent? So the experiment is rolling a pair of dice, and a trial is doing it once. 3 trials are doing it 3 times. Now, are the 3 trials independent? So don't look at the definition of independence, because here we need to classify independence from a qualitative point of view. So the outcomes of the first trial do not affect the probability of getting any outcome in the second trial. So of course, all the 3 trials are independent. Therefore, the outcomes, so they are independent, right? So let us define an event E I as, so let us define an event EI as getting sum equal to 4 in ith trial. So we have defined, this is a systematic way of solving probability questions. So define a random experiment. How many trials? We have 3 trials. Are the 3 trials independent? Yes, because whatever, if I get 2 or 3 in the first trial, it doesn't affect the outcomes of the next trials. Now let us define the event EI as getting a sum equal to 4 in the ith trial. And now what is the probability that we are interested in? So let us define a random variable x as x1 plus x2, where x1 is the number on first die or dice, and x2 is the number on, so not off, number on the second die. Now for this experiment, so what is the experiment? We are rolling a pair of dice thrice. Let us construct the sample space. Uh, so let us construct the sample space of this dice. So the sample space S is equal to, what are all the possibilities? Can have x1, x2. x1 can be 1, 2, 3, 4, 5, and 6. x2 can be 1, 2, 3, 4, 5, and 6. So corresponding to right. So corresponding to each a pair, you have one outcome. So this is the sample space. The sample space is the pair of the set of all ordered pairs x1 comma x2. So sample space is set of all ordered pairs x1 comma x2, where x1 belongs to 1, 2 up to 6, and x2 belongs to 1, 2 up to 6. So this is the sample space. Now, what is the random variable we are interested in? We are interested in the random variable x equal to x1 plus x2. And we are looking at the probability of x equal to 4 in a given trial. In a given trial, what are the outcomes that add up to 4? So you can have 1 and 3 adds up to 4. So this is, let me use a different color. So this box is adds up to 4. 2 plus 2 adds up to 4. And 3 plus 1 adds up to 4. No other outcome in this is in the event EI. So if we take the event EI, the probability that the sum of outcomes in each row equals 4 in exactly 2 of the 3 items is what? So the outcomes which are shaded in green color, they add up to 4. So what is P? And we assume that all outcomes are equally likely. Therefore, P of x equal to 4 is how many outcomes are in the number of outcomes in event I by the number of outcomes in the sample space. So what is the number of outcomes in the event I? It is 3. And the size of the sample space is 36. So this is 1 by 12. So P of x equal to 4 is 1 by 12. What is P of x not equal to 4? Yes, anybody? It's a simple thing, right?
11 by 12.
11 by 12. Okay, so this holds for all E. So now the P of EI is equal to 1 by 12. P of EI not happening is 11 by 12. And what is said? We need to find out in exactly 2 out of 3 attempts, EI happens. So let us look at the permutations point of view. Now it means that we have 3 blanks. So we have 2 possibilities. Either EI happens or EI does not happen. So out of the 3 times, any 2 times EI has to happen. Let me denote EI happening by, say, an X and EI not happening by O. So what are the possible combinations? You can have X, X, O, and you can have X, O, X, something like that. You can have O, X, X. So there are different combinations that are possible. So what is the thing? First, choose 2 out of the 3, right? And in each of them, and in each of them you have EI happens, and in one of the other, EI does not happen. EI bar happens. So bar is the complement of EI, right? So this statement, if you just translate to mathematical form, what is the act of choosing 2 places out of 3? So you have 3C2. EI happens in 2 of them. So now we have a binomial distribution. Binomial, or yeah. So if we have defined success as EI happens and failure as EI does not happen or EI bar happens, then the probability of n successes is given by x successes given by the um, x successes out of n trials. is given by the binomial distribution NCX. The probability of success is P power X, Q power N minus X. So this is a binomial distribution. This you know very well, right? So this is just this. Even if you don't know this, you can reason out as I did. So out of the 3 times, 2 times it has to happen, and 1 time it should not happen. And all 3 trials are independent of each other. So their probabilities can be multiplied with each other. So therefore, you choose 2 out of the 3. Then 2 times it happens means you have the independent event 1/12 into 1/12 happening, and 1 time it does not happen. So in other time you have 11/12. So what is this? This is 33, 11 into 3 by 12 cube. And this turns out to be 33 by 12 cube. So this is around 0.019097. And the question you're asked to round off to 3 decimal places. So this is 0.019. So this is the right answer. So this is by reasoning out. Alternatively, this is a random variable. The other random variable, if you treat as success or failure, right? For that, you have the random variable, which is the binomial distribution. So the probability of X successes in N trials is given by this, where P is the probability of success in 1 trial. And Q is nothing but 1 minus P, failure. So if you do it that way, the probability of 2 successes in 3 trials is nothing but 3C2. What is the probability of success in 1? We already have it is 1/12. What is X? 2. And the failure is 11/12. And what is N minus X? N minus 3 minus 2 is 1. So this gives the same answer, 0.019. So you can take either of the 2 approaches. In the first case, you reason it out. In the second case, if you remember the binomial distribution, you can use the probability of X successes in N trials. So I hope it's okay. If you have any doubts, you can ask me. So the next question is, we are given 2 probability density functions, f of x and g of x, where they are defined as it is. So which of the following statements is true? Here we are to deal with the mean and variance of probability distributions. Turn this off, it takes. So the mean of a probability distribution is defined as integral minus infinity to infinity x f of x gx, dx, where f of x is the probability density function. We have already seen that the mean x bar of a set of variables is nothing but summation xi by n, right? So this is for a discrete data. For discrete data, we take this as the mean, which is a measure of centeredness. So as n tends to infinity, the data becomes continuous. And this quantity 1/n tends to the probability density function. So therefore, the summation becomes an integral, and this is the expression for mean we have. So this is the expression for mean of a continuous random variable. And variance, if you remember, we call something as sigma square as the variance, which is summation I going from 1 to n, xi minus the mean x bar, the whole square, divided by n minus 1. Again, 1/n minus 1 is approximately 1/n when n is very large. And this is nothing but the probability density function. And we know that x bar is equal to mu in the case of a continuous random variable. So this is the mean. In the place of the mean of average of a set of data, you can put the mean of the continuous random variable. Therefore, for a continuous random variable, you can so for a continuous random variable, the mean mu is given as integral minus infinity to infinity f of x dx, and the variance sigma square is given as integral minus infinity to infinity x minus mu the whole square. In place of x minus x bar the whole square, you have this. In place of 1 by n minus 1, you have f of x dx. Now we are given f of x and g of x as shown. F of x is defined this way. You see, when x is positive, you have x by a, and when x is negative, in place of, so let me write it again. So f of x is 1 plus x by a, then x is less than 0, and 1 minus x by a when x is greater than 0. And 0 everywhere else. So this you can rewrite it as 1 plus x by a, you can write it as 1 minus x by a. And now if you take a closer look at this, you see that when x is negative, in place of x, you have a minus x. And when x is positive, you just have x by a. So you can combinedly write this as f of x is equal to 1 minus mod of x by a when x belongs to minus a to a, and 0 otherwise. So remember this, and then look what is the second function. Again, when x is negative, you have a minus x by a, and when x is positive, you have a plus x by a. So that you can again write it using the modulus function as g of x is equal to mod x by a if x is lying between this interval and 0 otherwise. So what is the mean of the distribution f? It is nothing but integral minus infinity to infinity 1 f of x dx, but you know that f is 0 everywhere outside of minus a to a, so you can reduce the limits of integration to minus a to a. 1 minus mod of x by a multiplied by x dx. And similarly, mu g is integral minus a to a mod x by a x dx. So the question doesn't ask us to calculate the values of mean and the variance. You just need to compute the, you just need to state whether the following statements are true or false. So the mean of f of x and g of x are the same. Is that true? Let us see. So in you know that mod is an even function. So whatever is inside the brackets. So this is an even function. This is an odd function. So the product of an odd function and an even function is an odd function. Right? If you have an x square and you have an x here, it will be the net is an odd function. It means this will not change sign. If you replace x by minus x, this will change sign. So the overall thing is changing sign. Product of an even and an odd function is an odd function. And here also, this is an even function. This is an odd function. So the net is an odd function. And the integrals are from minus a to a. You know that if you integrate from minus a to a function h of x dx, it is equal to 0 if h is an odd function. Because you know, right? So if you have something like this, this is an odd function. Sorry, this is not an odd function. This is an odd function. So the value from 0 to a, whatever area is there, that will be cancelled by this negative area from minus a to 0. So if h is an odd function, either integral is 0, and it is equal to 2 times 0 to a h of x dx if h is an even function. So if h is some function like this, these two areas both are positive, they'll add up from minus a to a. So in this case, the integrands are odd functions. So mu f is equal to 0, and the same is the case with mu g as well. So the means are 0 and they are equal. What about the variance? You can quickly guess. So the variance sigma square f will be 1 minus x by a, 1 minus mod x by a, x square. So it is x minus mu the whole square. Mu is equal to 0. So it is x square dx. And sigma g the whole square is mod x by a into x square dx. So these integrals go from minus a to a, minus a to a. But you can see that in this case, the this is an even function. This is also an even function. So this is not equal to 0. And here both are even functions. So sigma f square and sigma g square, they are, so sigma f square is equal to minus a to a, 1 minus mod x by a, x square dx, and sigma g square is minus a to a mod x by a, x square dx. So what is the difference sigma f square minus sigma g square? It is integral. So this is the integral is from minus a to a, so I can replace it as 2 times 0 to a. You get a 1 minus 2 mod, so 1 minus 2 mod x by a to x square dx. So this is not 0 in general. This is the first, if you integrate the first one, you get something x by 3. So it is something like 2a by 3 minus this, you can remove the mod. So you get some 2x cube. So that becomes x power 4 by 4. So it is a power 4 by 2a. There's also another 2. So that 2 gets cancelled. So this is something like 2a by 3 minus, so 2a, sorry. So this is x square. So you get a 2 into x cube by 3. So it is 2a cube by 3 minus you have a 4 a power 4 by 4a. So this is obviously not equal to, let me check, 2. Yeah, so this is not equal to 0. It is something that depends on a. Therefore, sigma f square is not equal to sigma g square. It is something negative. So the variances are different and the means are same. So the mean of f of x and g of x are the same and variance is different. So the correct answer is option B. So coming to the next question, the probability density function of a random variable x is given as it is a constant between 1 to 5 and it is 0 everywhere else. So let us look at that problem. So if you can sketch the probability density function. So it is something like this. From 1 to 5, it has a value of 0.25. This is f of x. This is x. What is probability of x less than or equal to 4? By definition, it is integral minus infinity to 4 f of x dx. But from minus infinity to 1, the function is 0. If it is 0 otherwise, therefore it is just integral 1 to 4 f of x dx. And what is f of x from 1 to 4? From 1 to 4, so 4 is somewhere here. It is 0.25 dx. So it is nothing but 0.75. 4 minus 1 is 3. 3 into 0.25 is 7.75. So the correct answer is option A. This is a simple question. And you can look at this question. This is also on a similar basis. So this I started discussing in the last session. So let me So the graph of a function is shown, and we can assume that outside of this interval from 0 to 3, f of x is 0. So f of x equal to 0 if x does not belong to 0 to 3. That can be assumed. So you have, this is the expression for f of x from 0 to 3. And what do we know that? We know the probability of the sample space is equal to 1. But what is the sample space mapped to on the real line? So the sample space maps to minus infinity to infinity. That is the definition of the random variable, right? So if you take a random variable x that takes one outcome and assigns a real number, and if and this happens for the entire sample space, so the entire sample space is mapped to the entire real line. So corresponding to s, the random variable is x less than or equal to the event s. The random variable interval is x less than or equal to infinity. So what is probability of x less than or equal to infinity? If it is a continuous random variable, you have it is integral minus infinity to infinity f of x dx. And this should be equal to 1 because the probability of the sample space is 1. Now we have a split definition and it is 0 everywhere outside 0 to 3. So this is nothing but just integral from 0 to 3. From minus infinity to 3, f of x is 0. From 3 to infinity, it is again 0. So it is nothing but integral 0 to 3 f of x dx is equal to 1. What is this? This is nothing but the area under the curve. So let us find out the area under the curve from 0 to 3. So this is one half, this is one portion, this is the second portion, this is the third portion. All three are triangles. So area is equal to area of the first triangle, which is half into base, which is 1 into height is h, plus area of the second triangle, which is half into base 1 into height 2h, plus the area of the third triangle, which is half into base is 1 into height is 3h. So the area is h plus 2h plus 3h, 6h by 2, which is 3h, and that is equal to 1. Therefore, h should be equal to 1 by 3. So the correct answer is option A. Now, this is an interesting question. So this involves serious usage of the random variables and concepts such as independence. Now, it is given that at a traffic intersection, cars and buses arrive randomly according to independent Poisson processes. So this is important at an average rate of 4 vehicles per hour and 2 vehicles per hour, respectively. The probability of observing at least 2 vehicles in 30 minutes is what? That is what we need to find out. Now let us again define so let us use the given data. So the arrival rate. So if you take the vehicle, if you take so arrival rate, if you express it in per hour, and if you express it in per 30 minutes. So if you take cars, it is given that they arrive at 4 vehicles per hour. So the average rate of arrival of cars is 4 vehicles per hour and buses is 2 vehicles per hour. So this is an average rate and this is per hour. But what we are asked to find out is the probability of observing 2 vehicles in 30 minutes. So in 1 hour, if 4 vehicles come at an average, in 30 minutes, at an average, 2 vehicles will come. So it is 2 vehicles per 30 minutes. And buses, 1 bus per 30 minutes. So this is one part of it. And it is given that they arrive randomly according to independent Poisson processes. What is a Poisson process? So Poisson distribution. So Poisson distribution is, as I said in the last session. So sorry, not this. Yeah. So if we are waiting on a highway and you're counting the number of vehicles which are coming, so the Poisson distribution relates to the number of occurrences of events. If you have rare events, for rare events, So assuming that if it is at a highway or something, if the traffic is quite low, then we know that the arrival of vehicles is modeled by a Poisson distribution. So in a given interval of some duration t, if it is in a given interval of some duration t, in this case t is 30 minutes, the probability of occurrence of x events, right? The probability of occurrence of x events is given as uh, 1 by x factorial m mu power x to e power minus mu. What is mu? Mu is the mean arrival rate in that t. So mean occurrence rate or mean arrival rate in that t. So what we have here is actually the mu, and x is x. We'll see x what it is. So this is the Poisson distribution. The probability of x occurrences in a given time interval t is given by this expression. Now we are asked to find out what is the probability of observing at least two vehicles. So it means we can have two vehicles, three vehicles, four vehicles, up to infinitely many vehicles. So the probability uh, so let us take x again, x equal to x1 plus x2 as our random variable, where x1 is the number of cars and x2 is the number of buses. So P of x1 is an independent Poisson process. So P of x1 is equal to mu1, which is the mean arrival rate of cars, power x1 e power minus mu1 divided by x1 factorial. And P of x2 is again an independent Poisson process. So P of x2 is mu1 power mu2 power x2 e power minus mu2 by x2 factorial. Now at least two vehicles means P of x greater than or equal to 2 is what we need to find out, but that is nothing but P of 1 minus P of x less than 2, which is nothing but 1 minus P of x is a discrete random variable. It can take only values 0, 1, 2, and so on. So it is 1 minus P of x equal to 0 minus P of x equal to 1. So these are the only two values, two discrete values, which is less than 2. Now that's all it is. So we already got the so this is the expression for the random variable. But what are the cases for x equal to 0? X equal to 0 means x1 equal to 0 and x2 equal to 0. This is the only possible. There should be no cars and no buses. What are the possibilities for x equal to 1? You can have either x equal to 1, x1 equal to 0 and x2 equal to 0, x2 equal to 1, or x1 equal to 1 and x2 equal to 0. So this, if you write it mathematically, it is nothing but P of x greater than or equal to 2 is nothing but 1 minus P of x equal to 0 is what? P of x1 equal to 0 and x2 equal to 0. And then what is the other case? Minus P of x1 equal to 1, x2 equal to 0. And what is the other case? P of x1 equal to 0, x2 equal to 1. Now it is given that the random variables, these processes are independent. Therefore, so these processes are independent. Therefore, P of x1 equal to 1, x2 equal to 0 is nothing but p of x1 equal to 1 multiplied by p of x2 equal to 0. So what is this? This is equal to e power minus mu1 power x divided by x1 factorial into e power minus mu2 power x2 divided by x2 factorial. So I can combine the exponentials, you get minus mu1 plus mu2, mu1 power x1, mu2 power x2 by x1 factorial, x2 factorial. Now let us evaluate the expression. So p of x equal to 0 is 1 minus p of x1 equal to 0, x2 equal to 0. So in the first case, you in this expression substitute x1 equal to 0, x2 equal to 0. So you get e power minus mu1 plus mu2, mu1 power 0, mu2 power 0 divided by 0 factorial, 0 factorial. Then what is the second case? x1 equal to 1, x2 equal to 0. So you get e power minus mu1 plus mu2, mu1 power 1, mu2 power 0 divided by 1 factorial into 0 factorial minus e power minus mu1 plus mu2, mu1 power 0, mu2 power 1 divided by 0 factorial into 1 factorial. So all the denominators are just 1. So this is 1, 1 factorial is 1, 0 factorial is 1, so it's just 1. Therefore, you can write it as so you can take 1 minus e power minus mu1 plus mu2, you can take it commonly out. So you get, so p of x equal to x greater than or equal to 2 is 1 minus e power minus mu1 plus mu2. You take this commonly out. What is left? In the first case, you just have a 1, right? Mu1, this is 0. This is 1. Here you have mu1 and here you have mu2. So it is 1 plus mu1 plus mu2. In the 30-minute interval, what is mu1? Mu1 is equal to 1. Mu1 is equal to 2 and mu2 is equal to 1. So you just substitute that expression, the values into this expression, you get it is 1 minus 0.19 something. So this turns out to be 0.199 or so. This value turns out to be 0.8. Rounded to 2 decimal places, you get 0.80. So the probability of observing at least 2 vehicles is 0.80. Yeah, rounded off to 2 decimal places. The probability of observing at least 2 vehicles in 30 minutes is 0.80. So this is the procedure. You list the given data. It is given as a Poisson distribution. Define the event. So define the random variable as sum of x1 plus x2, where x1 is number of cars and x2 is number of buses. Each of them evolve along according to a Poisson process. Then just write down the expression for the probability in terms of the individual cases. So x is greater than or equal to 2 means it should not be 0, it should not be 1. So they are independent events. So x equal to 0 corresponds to one outcome, and x equal to 1 corresponds to 2 outcomes. This is one outcome, this is another outcome. And then subtract the compute the two according to the given expression, and then you will get the probability. An important step or a common mistake you should avoid is note that these are given per hour. You should always recompute the average arrival rate or average occurrence rate for the time interval that they have asked. So if it is 30 minutes, you need to divide it by 2. If they have asked for 2 hours, you need to multiply it by 2. That should be taken care of. Okay. So yeah, almost that's the end of probability. If you have any questions, you can ask. You can post in the Google groups. We'll take it up. Next, let us look at the fundamental relationships between traffic flow parameters. So for that, let me go to this live session. Yeah. So we'll do it very briefly and then look at some of the problems in this area. So the reference where I have taken this content from is from this these two books. One is the book by Adolf May, 1990, Traffic Flow Fundamentals. That's a very good book, but it's very detailed. So the book is entirely on traffic engineering. So you may have to search in different chapters for the topics relevant to GATE. And the other is the course notes of CE 740 of Professor Tom B. Matthews from IIT Bombay. He has also held an NPTEL course on traffic engineering. So the notes are available for free online in his website. So that also you can consult. For traffic engineering is quite simple, as I said earlier. So there are only three fundamental characteristics of traffic flow. So fundamental characteristics are, if you have a road and you want to characterize a traffic flow on it, you just need three parameters. One is the flow, which is a measure of volume of vehicles. How many vehicles are passing through it? How many? So it is measured in vehicles per hour, and it is measured at a point. So if you have a road, you can have a road like this. And let us say you measure the distance along the road by x and the time as t. So we have two independent variables with respect to traffic flow. Similar to fluid mechanics, you have two independent variables because conditions on the road change with space and with time. So closer to an intersection, you can have more traffic jam. Somewhere in the middle of a highway, at the same time, you can have very free flow of vehicles. Similarly, if you have at different points of the day, you can have different flow at the same point, at the same spatial point. So the fundamental characteristics are either a function of time or as a function of space. So flow is the number of vehicles per unit time, and that is measured at a given point on the road. So x is fixed, and flow is represented by the letter q, and it is always a function of time at a given x equal to x naught. So this is one fundamental characteristic. The other one is speed. So speed, again, it depends on how we describe speed. So speed is usually, as you know, it is meters per second, kilometer per hour. These are the units. This is a measure of how fast the vehicles are moving. But there are different. So if you talk about an individual vehicle, the speed of an individual vehicle is a function of both x and t. So it is the speed of an individual vehicle is a function of both x and t. So vehicle while traveling here, it can be of low speed, it can go somewhere else. So that is called spot speed. So where we treat the vehicles as a particle, individual particles, and the spot speed, as you know, it is defined in the usual physics-based definition, dx by dt, the rate of change of distance with time. So that is the spot speed of a vehicle. You have other measures of speed called time mean speed and space mean speed. So if you give a fixed time, if you fix the point at which you're measuring the speed. So you take the speeds of all vehicles passing through a given point in a given interval of time, and then find out their average. That is called time mean speed. Alternatively, you take a given stretch of the highway and take an aerial photograph of it. Whatever vehicles are present in that stretch, take an average of their spot speeds. That we call it as a space mean speed. We'll define it more rigorously. But the fundamental characteristics are, one is the flow of vehicles, the other is the speed of the vehicles, the other one is density. So speed is a qualitative parameter. So if we go faster, it typically means the road is performing better. And flow and density are some parameters that are used to design the road as it is. So we'll look at it in detail. So flow, as I said, is the number of vehicles that pass a given point. So flow is number of vehicles passing through a given point in an interval. It is measured in an interval. Can be say T1. So as I said, you have the road, you put an observer here, and there are vehicles coming all the way. So you take the you see at what say you start from T1 is equal to 1 p.m. to T2 equal to 2 p.m. In 1 hour, you can measure how much is the flow. So that is that's called the flow. So Q is NT divided by T, where it is NT the number of vehicles recorded in the time interval T1 to T2, and Q is a function of T. So that is the flow. And you can report the flow in various forms. You can call AADT, which is average annual daily traffic, average annual weekday traffic, average daily traffic, and average weekday traffic. So average annual daily traffic is you. So the first A stands for average. This means annual. So it is averaged over an entire year. What? It is the daily traffic. So T1 is the start of the day, T2 is the end of the day. So we measure the flow over a period of 1 day. So that is the daily traffic. You measure it every day and then take the average divided by 365. That is the average annual daily traffic. WT means you would just take the weekdays, excluding Saturdays and Sundays, because the traffic characteristics on Saturday, weekends and weekdays are very different. And these two, you just see A is missing. It means it is not over annual. It may be 6 months, it may be 1 month, or it can be any shorter duration. So these are the various measures of flow. Then density is the number of, so density is the number of vehicles occupying a given stretch of road. So when we say in a given stretch of road, it is x1 less than x less than x2. So density, how do you measure? You say you have a road like this. You take 2 points, x1 and x2. In between x1 and x2, there will be vehicles. You'll have vehicle here, you'll have vehicle here, you'll have vehicle here, you'll have vehicle here. So you see how many, you count how many vehicles are there between x1 and x2, and then density is denoted by k, and divided the number of vehicles between x1 and x2 divided by the length of the road, x, which is x2 minus x1. So this is the density of traffic at time t. So this is at a fixed time. This is measured at fixed time, say t equal to t now, and this is at fixed space. Fixed point is equal to x naught. So this is how you define the flow and density. So these are called the macroscopic parameters of traffic flow, because you're not dealing with individual vehicles. So microscopic aspects are those that deal with the individual vehicles. For example, the spot speed is a microscopic measure, and density, flow, these are macroscopic measures. So this is one flow, this is one table which you can remember. So traffic flow parameters can be either let me. So as I said, there are only 3 basic traffic flow characteristics or parameters, which is flow, speed, and density. So there are macroscopic versions of that and microscopic. So microscopic quantities are to do with the individual vehicles. So macroscopic, as we already defined, one is the flow rate Q, which is called the flow rate or the volume of vehicles. And the other is speed. So speed is a microscopic. So if you say spot speeds, is a microscopic characteristic. Density is again, you're looking at multiple vehicles at a time, so it is a microscopic characteristic. Now, these are also related to certain other characteristics called headways. So one way is, so for example, if you consider same thing, you consider a point on a given road and you put an observer here. Instead of counting how many vehicles pass in a given time interval, this person can also count, this person can also get the time gap between two successive vehicles. So you call something called the time headway. So the time headway is the time difference between two successive vehicles when they pass a given point. So this is a microscopic characteristic. Instead of counting the total number of vehicles and dividing by the time, you can measure how much is the gap between individual vehicles. So towards this, what is very useful is what we call a space-time diagram. So this is time, this is space. This is also the distance along the road. For an individual vehicle, if you take a given vehicle, it will start at some point in time. It will have an initial location, and then it will travel along the road at some velocity. So this is the characteristic of an individual vehicle. But there are many vehicles on a road, right? So you can put, so another vehicle can start a little late. Another vehicle can start at a different point and go at a different speed. And another vehicle can start somewhere here and go at a some different speed. So you can have many vehicles like this. So each color that I have drawn here corresponds to one vehicle, which describes the position of that vehicle with respect to time. So this is called a space-time diagram. And how do you measure the flow rate? So we'll see how it is. So as I said, a flow rate is at a given x. So we need to choose a given x. So suppose I fix x equal to x naught. It is somewhere here. So flow rate is at x naught is measured along this line. And it is measured over a given time interval. So the time interval is, say, t1 to t2. Now, at this point, how many vehicles are going between? How many vehicles are recorded passing through the point x0 from t1 to t2? So there is 1, there is 2, 3, and that's all. So between t1 and t2, three vehicles have passed. So the flow rate is 3 by t2 minus t1. So this is the flow rate in this interval measured at the point x. And similarly, the other component is the distance headway. So the other component is, so this is the time headway. So if the time of observation is t, you know it should be the sum of the gaps between successive arrivals. So it is summation I equal to 1 to the number of vehicles n, it is hi. But we know that the summation up to n, right? N itself, the Q is given as number of vehicles by time, which means it is number of vehicles by summation I equal to 1 to n hi. Now we can bring this n to the denominator, so you get 1 by summation hi I equal to 1 to n divided by n. So this is nothing but the average of the time headways. So it is 1 by h average. So this is a very important relationship between the time headways and the flow rate on a highway. So the flow rate is also measured at a given x. The time headway is also measured at a given x. You take the average of it. So time headways between two successive vehicles. So it is to deal with every vehicle. So it's a microscopic quantity. And both are not independent. Q depends on time headway as. So in the last column, let me write down the relationship. So if you remember this table, it will be very helpful. So Q is related as Q is 1 by H average, the average of the time headways. Let us call it H. A speed will come to it later, but density. So related to the density is something called the distance headway. What is the distance headway? Again, consider a road stretch. So remember the distance headway is not, it is at a given instant of time. So there are vehicles everywhere. At a given instant of time, you're looking at one stretch of the road. So you're taking x1 here and x2 here. And you are taking a snapshot in time. So at that instant, how many vehicles are occupying this? That is the density. Distance headway is when you take the snapshot, what is the distance between two successive vehicles? So this can be say S or spacing. You can also call it as the spacing. So let us call this S1, S2, and so on. So the distance headway is the distance between corresponding points of two successive vehicles at a given instant of time. So corresponding points means if you take the distance from the front side of a car, you should stop at the front side of the other car. If you start from the back side, you should stop at the back side. So that is just the meaning of corresponding points. When the distances are very large compared to the vehicle size, it doesn't matter. So again, so it is denoted by S. So again, we can say that the sum of all spacings should be equal to the length of the road stretch, which is x2 minus x1. And we have defined density as the number of vehicles in that road stretch x divided by x. Therefore, the sum of all headways, the sum of all distance headways is equal to what is x? X is nothing but nx by density kappa. So rearrange this relation. So you get x is equal to nx by density. Now again, you can bring this nx to the side, which means density is equal to 1 by summation si from 1 to nx, the total number of vehicles in that, divided by 1 by nx. So this is nothing but 1 by S average. So this is another critical relationship between the macroscopic and the microscopic parameter. K is the density at a given time instant, and S is the average spacing of two successive vehicles in the thing. So here, corresponding to the microscopic parameter corresponding to density is distance headway, which is denoted by S, and the relationship is K is equal to 1 by S average. So we are running out of time. So we'll look at speed in the next session. Just to get the concepts clear, let us look at one problem in based on space-time diagram. So this is from the latest GATE exam. So the figure presents the time-space diagram when the traffic on a highway suddenly stopped for a certain time and released. So this is time, this is distance. As you can see, there are many vehicles here. So we just need to observe the options. And in a time-space diagram, the slope dx by dt of an individual curve. As I said, each curve corresponds to one vehicle. So dx by dt of an individual curve is what? Dx by dt of the individual curve is nothing but the spot speed of that vehicle at that time and that space. So if you consider this vehicle, if you take this vehicle, it goes from here, it goes here, and then it goes here. So this vehicle, if you are if you're interested in that spot speed, you take one point x comma t and then take the slope of the curve at that point. So that is the spot speed. So dx by dt of the individual curve in this space-time diagram is the spot speed. Yeah, other quantities we can actually find out as we'll see. So speed, the first option says speed is higher in region R than in region P. Is that true? That is not true. You can see the slope here is smaller than the slope at P. Visually, you can see this arrow is steeper than the arrow in the region R. So this option is wrong. Volume is the other name for flow rate. So volume is lower in region Q than in region P. How do we define volume? So Q, we already saw it is nothing but 1 by the headway, average headway. That is the relationship. How do we measure headway? So you take, so the time average headway is, so the average time headway is, you fix a given point in space. For example, you fix here, x equal to x naught. So let us call this xq, and let us fix another point xp. And let us consider the same time interval. T1, T2. So in this time interval, in XP, you see that there are 1, 2, 3, 4, more than 4 vehicles cutting through this line. But in the region Q, you see there is only hardly one because the slope is very small, hardly one vehicle will fit. Therefore, here there are more number of, and here the time headway is smaller, here the time headway is very large. Therefore, the volume in region Q is less than the volume in region P. That is true. Then what is the option C? Volume is higher in region R than in region P. So region P, we have already drawn this thing. So in region R, again, you consider, say, T3, T4. Take a given instant XP. So here you have 4 vehicles. In the same interval, you take another XR. Here you have more than 4 vehicles cutting to the point. So the volume in region R is obviously higher than region P. So this is also a correct statement. The last one is density is higher in region Q than in region R. So for density, as I said, is defined in a given instance of time. So fix T is equal to TQ here. And fix T is equal to TR here. Again, as usual, consider the same time window in space. So call this x1 to x2. So in region Q, you see there are many lines cutting through this vertical TQ. Sorry, this is TQ, right? So in region Q, you have more vertical lines, more horizontal lines cutting through this. But in region R, in the same x1 to x2, you have, so let us take this as TR. You have only 2. So here you have more than 4. Here you have only 2 because this is steeper. So as you see, the density, if you take a vertical line, more horizontal lines are cutting through the vertical line in region Q than in region R because here the lines are flatter, here the lines are steeper. Therefore, the density is higher in region Q than in region R. So the correct answer is, it's a multiple select type question, B, C, and D are the correct answers. So the other questions are also simple. Other questions and the relevant topic we'll look at in the next session. If you have any doubts, I'll stay back. You can also post it in the Google groups. Yeah, I'll stay back for a few minutes. If you have any doubts, you can ask. And if not, we can end the session. Yeah. Any doubts, Dharani or Shailin?
Sir, in the probability density functions, the The area under the curve is the probability you calculated, and
Yeah,
for the calculation of the mean, you write the integration of fx into x dx. Yeah, x into fx dx. So
yeah.
what does it mean in the geometry wise?
It
Is
means okay, in the geometric sense, it is something like the moment. So it is like the first moment. Let me put it. Yeah. So the idea is mean is something like an expected value. So mean is also known as expected value when you deal with distributions. So, for example, if you perform a random experiment infinitely many number of times, mean is something that uh, probability you understand. So, if you say what is the probability of x less than or sorry, random variable x than or equal to a given x, it means you know what is the likelihood of that event happening. So that is something like you define a value for the random variable. That is, you define the event. What is the likelihood of this event happening? That is the probability. That is a number from 0 to 1, which is the probability likelihood. Mean is something like expected value. Now we don't tell you the probability. We give the distribution. So an example can be, suppose you have a biased coin. So you have a biased coin. No, biased coin. Okay, fine. Let it be. You have a biased coin and you toss it infinitely many number of times. You can determine the probability of head. So if you say head is equal to 0, and this is a discrete distribution. Some continuous. So you can look at the vehicle arrival rates. So for example, if you have this uh, same thing, if you stand at a point in a highway and then vehicles arrive at random intervals, right? So the headway is something randomly distributed. So if you look at the distribution of the time headways, that you take the measurements over a period of time and you measure the difference between successive arrivals. So your random variable, you can treat it as the time headway h, and corresponding to every headway, there is some probability. So uh, you can record various headways and the corresponding frequencies. It will be distributed in some fashion. So that is a so corresponding to every headway, there is some frequency. That is the probability of that headway. But suppose we do the experiment forever. We stand at that point and keep counting an infinitely large number of vehicles. What is the expected headway? Assuming that the headways are all randomly distributed, what is the expected headway? That is the mean. In the case of a coin tossing experiment, if you assign x equal to 0 for head and x equal to 1 for tail, you perform the experiment. If it is a fair coin, you perform the experiment infinitely many number of times. What is the expected value? It is some you can't determine. So you will get an expected value of 0.5 or something. So uh, because it is something, both are equally likely. So the expected value is something like 0.5. That is the sense. From a geometric point of view, um, if you have the distribution function, something like this, f of x dx, sorry, x. If you take the area of the curve between 2 points, x1 and x2, the area is the probability of x1 less than or equal to x less than or equal to x2. So this is the probability. The area is given by the probability is given by the area, and expected value is something like, or the mean or the expected value is the moment of the area about the origin. You have a distribution like this, and this is the origin, and it's like at what is the expected value? So you take the moment of this area. So this is the area under the curve. You take the moment of, you take a small strip here, which is the area of that strip is f of x dx. and you multiply by the distance from the origin. So f of x dx into x. Integrate over 0 to infinity, minus infinity to infinity. That is the moment of the area under the curve. And now this has something like, so if you take the area under the probability density function and you want to support it at one point, right? You want to just support it at one point, which point it is. That is the idea. Suppose this this area under the probability density function is loaded by gravity, and you want to support it just at one point where the moments due to the gravitational forces are balanced. That point is the expected value. So that also physically makes sense. Over an infinitely large number of trials, what is the expected value? That is x. And alternatively, you take the area under the curve and you support it just on the one point. That is the expected value, which means this value is kind of representative of the entire distribution. That is what it means. So what is the value that is expected when you perform infinitely many trials of the experiment? That is the expected value, and that is the moment of the area under the curve about the origin. So it is moment of area under the curve about the origin. About the origin is important because variance is also a moment. About the origin. Again, variance is also a moment. That is the second moment. So if you think of this as the center of mass of the, so this is something like center of mass or center of gravity of this area under the curve. Variance is the moment of inertia. That is something like the second moment. So variance, if you see, it is minus infinity to infinity, x minus mu the whole square, f of x dx. Now, if you look at it in the same way, we have already determined mu as something. So if mu is this, you're taking the second moment. So this is x minus mu. This is the x minus mu. At a distance of x minus mu, you have an area f of x dx. So you take this strip x minus mu the whole square. So on both sides, you take this strip and run it from minus infinity to infinity. So this is the second moment of something like the moment of inertia. So it is the second moment of area under the curve about the mean of it, about the mean itself. Again, this is a measure of the spread, right? So similar to the moment of inertia, the same area you can give, you know that I section has a bigger moment of inertia because it has spread the material far away from the centroid. Similarly, variance is a measure of the spread of the distribution. So when you take the second moment of something, it measures the spread. So that is the second moment of the area under the curve. And similarly, there are third moments also, but that's not important from gate point of view. That is the skew and things like that. So variance and mean should be enough. So is that okay?
Yes, sir. Thank you, sir.
Yeah, thank you. Yeah, if there are any other doubts, I can stay back, and if not, I will end the session.
Thank you, sir.
Yeah, thank you. So the next session we are planning for problems. There are a few problems left in traffic engineering which are simple, based on some graph and direct application of formula. Last time I didn't upload it, but this time let me upload the questions. You can try it out and we'll discuss in the first 20 minutes or so, 15-20 minutes. Then we'll look at open channel flow in open channels. So the basic definitions, flow, critical depth, things like that, gradually varied. So that is also an important topic in GATE. We'll look at that one in brief, and then we'll look at questions in the succeeding session. Yeah, I'll post it, and you can also find the planned topics in the GATE website. So yeah, so that is the end of today's session. Thank you. We stop the recording.